Have you ever wondered how a relay works in circuits automation? Well, prepare to have your curiosity satisfied. A relay in essence is an electromechanical device that allows for control of a large electrical load using a small input current. It's akin to a switch but with a key difference: it's operated electrically, rather than manually. In the world of electrical circuits, relays play the quintessential role of the middleman. They bridge the gap between low-power control circuits and high-power devices, allowing for safe and efficient operation. By doing so, they provide the critical function of automation. In today's electronic age, this role is more important than ever. From home appliances to industrial machinery, the automation facilitated by relays is at the heart of the modern conveniences we often take for granted. That's the basic idea of a relay. Now, let's delve into how these impressive components actually function. Understanding the inner workings of a relay might sound complex, but it's actually quite straightforward. A relay is essentially an electrically operated switch. It's used to control a circuit by a separate low-power signal, or multiple circuits by one signal. At the heart of a relay, you'll find four key components: the electromagnet, the armature, the spring, and the set of electrical contacts. Each of these plays a crucial role in the relay's operation, so let's break down how they all work together. First up, we have the electromagnet. When an electrical current passes through the coil, it generates a magnetic field. This is the driving force behind the relay's switching mechanism. Now let's talk about the armature. This is a movable iron piece that's affected by the magnetic field generated by the electromagnet. When the electromagnet is energized, it creates a magnetic field that attracts the armature, causing it to move. Next up is the spring. The spring is connected to the armature and it's there to return the armature to its original position once the electromagnet is no longer energized. It's like a reset button, ensuring the relay is ready for the next cycle of operation. Finally, we have the set of electrical contacts. These are essentially the switch part of the relay. The armature is connected to a moving contact that can either establish or interrupt a connection with a fixed contact. When the armature is attracted by the electromagnet, it either opens or closes the contacts, depending on the type of relay. So, in a nutshell, a relay works by using electrical power to create a magnetic field, which then activates the armature. The movement of the armature can then open or close a circuit, thanks to the set of electrical contacts. When the power to the electromagnet is cut off, the spring returns the armature to its original position, ready for the next cycle. And that's how a relay works. But how does this translate into real-world applications? Relays are not just theoretical devices, they play a crucial role in many of our everyday technologies. Let's take a closer look at how they shape our world. In our homes, relays are key components in appliances like washing machines, refrigerators, and air conditioners. They enable these devices to safely manage high-voltage power, all controlled by low-voltage signals. On the road, relays are the unsung heroes in our automobiles. They're responsible for functions like turning on headlights, activating windshield wipers, and even starting the engine. Without relays, our cars wouldn't be as safe or efficient as they are today. In the realm of industrial machinery, relays are essential too. They allow for precise control over heavy-duty equipment, making operations safer and more efficient. So, next time you use an appliance or drive a car, remember the crucial role that relays play in making these technologies work.